We can also just start out with the kinematics and have our z equals 1/2 at squared plus v0t plus z0. Now we're making our initial position up here is 0. And so that means when we get to the bottom, that's going to be minus z, or minus delta z minus the height. So we have 1/2 g, and the time if we hadn't gotten this expression up here before, we can just leave as time. And the v0t, since we're starting at the top, is 0. Excuse me, I labeled that incorrectly. We're going to have minus z. This is 0. And our initial position is 0. So we have minus z equals 1/2 gt squared. And then solving for t, we get t squared is minus 2z over g, and g is minus 9.81, so we don't have to worry about dealing with imaginary numbers. The negatives cancel each other, and we're left with t is the square root of 2z over g, which is 2y over g, which is 2hx over g, and is equal to 2hy over g. And that is the expressions for the times. But this is perfectly satisfactory. And although it's not required, I would explain it like this. The time up equals the time down. Maybe even use the word symmetry. Even having a picture like this, t and t, makes it clear what you're doing, because this was the intended answer. I would never do that. It's just because we just arrived at that equation by doing the reverse thing. But in any case, that's how we can get C, and you get full credit and just add the annotations where correct. So now we go to part DI. Correct aspects of reasoning identified in A were expressed in your mathematical relationships in part B. Well, let's go look and see what we had in part B. Part B was y equals v0 squared over g. And we had t is v0 over g. So the correct reasoning, how do they come to bear on those two things? So in part A, correct. Same vertical displacement. So they said the same vertical displacement. So what we can say is student 1, was that student 1 or was it student 2? Student 2. Let's start with student 1. So the kinetic energy doesn't have any bearing on it. And that it would take less time to hit the ground if it was a shorter height. Student 1, shorter height would take less time. According to those two equations. And that happens because smaller y means smaller v0. And smaller v0 means smaller time. So again, if we have a shorter height, that would be the result of changing the v0. The v0 would be smaller, would produce a smaller y. And gravity is gravity. That's not going to change. So that's the first part. And secondly, if we then have a smaller v0, again, gravity is going to stay the same. The time will be less. So that's student one's correct thing. And the kinetic energy doesn't relate to either of those two questions. We go on to to those two equations. We look to see yes, and as we get to student 2, the same vertical displacement. Student 2, same vertical displacement. The only difference between x and y was the mass. And neither equation depends on the mass. So their heights should be the same. So again, this question, what makes it trippy where people slipped up is they ask you to reference your own mathematical relationships. So you've got to pull things from your part B. And then they want to know the student's reasoning, the correct aspects, applied and explain. Okay? And that's the key word here. Again, we've got to explain these things. How is it that these two things are related to the student work? And now they want to know, this is the same question, the correct aspects are expressed in your relationships in part C. So we go to part C. And we have the same thing here, which is T equals V0 over G, same relationship. And we had T equals square root of 2hx over G. And T equals the square root of 2hy over G. So again, we have correct aspects here. The kinetic energy doesn't relate at all to our equations, since these are all kinematic equations. So shorter height will take less time is again confirmed. Student 1, shorter height, less time is confirmed. And we can see this smaller hx or hy results in smaller time. Student 2, their correct thing they said was the vertical displacements are equal. Confirmed. Neither equation equations output of time or height depends on the mass. And that is the first FRQ.